Now we will be trying to find out Thevenin equivalent circuit for a given circuit. This is the given circuit. So we're going to find the Thevenin equivalent of it. That means we're going to calculate that Vth and Rth. How we're going to find the Vth is the first step, and this video tells us how we calculate that Vth once the circuit given to you. So we don't have to memorize anything. Just by looking the circuit, we can find out the rule that we should follow. Rule is this: if we keep these terminals open circuit, that means no current here. That is open circuit. No current means open circuit. Then, since Rth is serial, this current is so equal to this resistor's current, which is 0, multiplied the resistor's current with its resistance gives you the voltage. So since the current is 0, the voltage is 0, that voltage is 0. If that voltage is 0, then Vth is equal VAB. Rule is this: Vth, the thing that we are going to calculate, is equal to VAB, which is the open circuit voltage of the terminals A and B. So that's the rule. So how I am going to apply that rule? We've got to go back to the given circuit. So we're going to come to this. When you come to this, so this is open circuit, nothing connected to it, open circuit, no current passing through here. And when it is open circuit, I am going to calculate that VAB. In this example, this VAB is so this open circuit voltage is an element voltage at the same time. In this example, it is like that, but in some other examples, this voltage may not be an element voltage. It could be more than one element voltage in some cases. So in this one, it is a simple and it is an element voltage. So because of that rule, the conclusion we end up with is that to calculate one of the elements voltage, the problem becomes this problem now. So if you want to apply the classical the methods that we have seen already, what are they? The classical method, mesh current method, node voltage method. These methods are for finding all the elements current and voltages. Now what we require in this case is just one element voltage we need to calculate, and this element voltage is going to be my Thevenin voltage. Therefore, no need to apply the mesh current or node voltage method here. Since the circuit is simple, we could do it by manually somehow, without any method. Just we can use our mind. So let's do it then. So there is a mesh here. If I write Kirchhoff voltage law equation for this mesh, I need to choose a mesh direction. Let's say this. So this is independent voltage source. Independent voltage source current reference is going to be downwards according to passive sign convention. So let's write this Kirchhoff voltage law equation, Kirchhoff voltage law equation for this loop. So this direction and this direction opposite to each other, so -8. And directions, this resistor and this mesh direction is the same, so it is plus. The voltage of this element is 10 kE. So that is the voltage of this element. And the last one, the direction, this is dependent voltage source, voltage controlled voltage source. So this current reference is downwards according to passive sign convention. So directions are the same, plus the voltage of this element. The voltage of this element is equal to V. V is VAB. So V is equal to VAB, the voltage that we are going to calculate. So that means the voltage of this dependent voltage source is going to be 3 VAB equal to 0. So we wrote Kirchhoff voltage law equation for this loop. Now, in this equation I have got VAB, the thing that I am going to calculate. So I have seen that I here. I don't want to see that I, because I would like to transfer this I to VAB, and then I can calculate that VAB. So how I can get rid of from that I there? So I come back here and consider, make it different color, Kirchhoff current law equation for this node. So this current, this is current controlled current source current, isn't it? 10I. So 10 of this I. So this resistor current, if this V voltage has been chosen as the voltage reference, then it's going to be resistance current downwards according to passive sign convention. So if I write the Kirchhoff current law equation for this node, it's going to be 10I plus this resistor current. This resistor current is this voltage divided by 3K. This voltage is my voltage that I would like to calculate. So VAB over 3K equal to 0. What I wrote here is Kirchhoff current law equation for this node. And this is, what is this current? Is this current. So this is 10E, I add them up, so we ended with this one. So this equation tells me that I can get rid of from that I. How? I could get it out. So 10IE is equal to minus VAB over 3K. So there is a 10IE here, so I can write it here, minus 8 plus 10IE, so I keep the K as it is, K times 10IE, actually 10IE equal to minus VAB over 3K. So I'm going to transfer it to here, 10IE, K times minus VAB over 3K plus 3VAB, make it simple, equal to 0. So this K is gone, and put that 8 on the right hand side. What I end up with is minus 1 over 3 plus 3 VAB is equal to 8. So that gives me 9 minus 1, 8 over 9. Not 9, 3 of course. Isn't it? 3 times 3, 9, minus 1 gives you 8. 8 over 3 VAB is equal 8. Then VAB is equal 3 volts. So that means from here VTH, the thing that I am going to calculate, that I wanted to calculate, is 3 volts. So that's the end of it, end of this.